Is it visible?
Yes, ma'am.
Yeah. So today I'll discuss a little bit about parameterized constructor, and I think copy constructor has already been done by sir. So I'll discuss one or two example, and then I'll discuss the destructors. Okay. So have you understand what is copy constructor and how it works?
Yes, ma'am.
Okay, so this one is just I'll be showing you constructor overloading. So we all know that the use of constructor is that whenever we will be creating the objects, they will get initialized at the same time. So the same thing can be done with the overloading because we need different constructors. We can have either the constructor with no argument, or the constructor with two arguments, or the constructor with one argument with default value, etc. Okay, so here I have included one example where I'm showing that there are two private data members, length and breadth, and then in the public section we are writing the constructors. So here you see this one, just a second. Okay, so in uh, here this one is not taking any argument. Okay, and this one is taking two arguments, L and B, and this is initialized. Okay, so all the constructor, they are having same name as the class name, and the last constructor is having one argument. Okay, so here there will be one break. Okay, one argument. This constructor is having only one argument, so it is writing down this argument value as 7.2. So every time the third constructor is called, the value of breadth is 7.2. You cannot change it. It is fixed. Okay. So here you see in room 1, room 2 and room 3, three objects are created. So for the first one, this one will be called. And for the second one, the number of arguments matches. So we know that whenever there are overloaded functions, that means the function having same name but different number of arguments, and the type and the order of the arguments that we are passing maybe differ. So you know that how the compiler converts. Okay, if it is double double, it will convert room that this one as underscore double double. Okay, or if it is one only one double, so it is converting the room underscore double, like that. So we know that. Okay, now here we are introducing a new thing that is not new, rather we are making this thing as fixed. So this 7.2. Okay, so can you remember the thing that we have discussed, default arguments? Do you remember the default argument thing?
Yes,
Yes,
ma'am.
ma'am.
So the rules related to default argument is that we can pass the default values to any argument, and then that will be from this right to left we can assign. Okay, and we cannot do them. There are certain rules we need to maintain when we are passing the default arguments. But whenever we are writing down different arguments, that they can be overridden by that. Means the default argument will be overridden, and we will be considering the local one. Okay, so that those were the rules. So here this thing can also be done with, here you can write down breadth equals to 7.2. You can write down this b equals to 7.2, like you are writing here double b, so we'll be writing double b equals to 7.2. Okay, so we can do this one also. So here two things we are doing. Here we are doing overloading, function overloading, function overloading, and we are not passing any default argument, but we can do that. Okay, so for understanding constructor or for using constructor in your program, you always require the this overloading idea of overloading. Okay, so next is I'm just briefly discuss the copy constructor that has been discussed by sir. Just the same example I'm taking in a different view. Okay, so here for copy constructor, can we do that? That means can we initialize an object for another object? So this one is our aim of doing object oriented programming, is that we will be replicating the built-in data types as our user defined data types. That means our user defined data types will be acting like the built-in data types. So built-in data types is int. Okay, so if I consider this example, int x equals to 10, and then we do this thing int y equals to x, that means y value of y is initialized by the value of x. We are copying all the values of x to y. So can we do that using the concepts of objects, because objects are the built-in user defined data types. Okay, so like this we have discussed that can we do this stack 1 equals to stack 2. Okay, so that means we are trying to create objects by copying another object. Okay, and what we are doing here, we are just having a simple class xyz. There I have written one constructor. This is the default one, and this is the parameterized one. Just we are means initializing a with this parameter p, and here a is with 0, and we are displaying a. Now we are creating three objects. First is x1. So x1 is not passing any variable, so this one will be calling the default constructor, that is the first one. Okay, and x2 is passing 10. Okay, so this its data type is matching with this int p, so the matching constructor is called, and this one will be calling, so this one will be calling this one. Okay, and this one is calling this one. Now consider this line here. We have written x3 equals to x2, but is there any constructor defined for this kind of, to support this kind of thing? No.
No.
Okay, so if you are not defining anything, even if you are not defining any other constructor that supports this type of function, compiler provides one default copy constructor. Okay, so what is copy constructor? That I think you have already known this thing. Okay, so it is working fine. This x2 is copied to x3, the value of x2, that means a value is copied to x3, and whenever you do x3 equals to show, it is showing 10. Okay, so this one is working fine. Till now there is no problem. Okay, so what the compiler does, compiler here, it provides a default copy constructor. Okay, which bitwise copy x2 to x3. Okay, that means whatever be there in x2, it is copying as it is in x3. Okay, so this is fine. The copy constructors are fine. Now there are certain problems related to the copy constructor. So the word copy and the word constructor. So we will be taking these two words. Constructor means constructs object, constructs new object, How? By this copy method, by copying some old object, existing object from the same class. Okay, so that's why it is known as copy constructor. That's why this definition comes. Okay, so the problem that is discussed yesterday, I'm taking the similar example. Okay, so just a recall thing. Okay, so here if we take this type of constructor, so you just consider the line by line. Here I am taking integer a and one pointer. Okay, what the pointer does, so this is whenever we create any object, the object will be having these two members, a and star ptr. Okay, so star ptr is a pointer which stores the address of the first element of the array. Okay, so what we are doing with this, for the first constructor default one, we are assigning a is equal to 0. For the next one, if we are passing any value for p, first we are creating one array with the value of p. Okay, so with this line ptr equals to new in ptr we are creating an array of 10 integers. Okay, with this p because we are passing here 10 for the first one. Okay, so let us take it as 10 for this one for x1. So x1, whenever you create x1, it will assign a as 10. It will create an array with 10 integers and the first element, that is p, first element is stored in the star ptr. That means star ptr means value at ptr. Okay, so its value is also 10. So I think this is fine. Okay, and then a simple function called fb, that is passing one integer k and it is changing the value of the ptr. That means whatever ptr is pointing, the value of ptr is changed as k. So why we are keeping two different functions? For here also we are initializing ptr with p, here also we are initializing ptr with k. Okay, so why we are keeping two functions, that I'm coming next. Okay, so now you see in void show we are just printing value of a and value of the pointer. So the difference between these two function is these two program is, here no member is having pointer variable. Okay, no member is pointer, but here we have taken one pointer. So there are certain problems that occurs if you take some pointer, if you have pointers as an argument. Okay, as a member variable. So what happens, let us see, we have created some of the objects. Okay, 4 objects we have created and we have created here one block. See, one block. Okay, so for the time being, just you understand what destructor is. That already sir has discussed, that if I call a destructor explicitly, if I call a destructor, it is just showing destructed. Okay, if you are not using this line, then also it will not show you any error, but we have included this line just to show you that when such particular constructor means particular object is destructed. Okay, so whenever any object where it is defined or declared, whenever it comes out of that block, it will be destructed. Okay, so now let us see this one. So let us see the line by line execution. Okay, so here in x1 what happens, we are passing 10. So 10 means value ptr is it is pointing to an array of 10 integers. Then the value of ptr is stored as 10 and value of a is also stored as 10. Okay, and we are showing this one. Okay, so the output for x1, this one for x1 dot show, it is showing a equals to 10 and star ptr equals to 10. Okay, now this is fine. Next we are initializing one more object with 20. Okay, so whenever we do 20 for x2 also, this is done. A equals to 20, this will be actually 20 units long. Okay, means space is not there, that's why I have not drawn in that way. Okay, so this is 20 units long and ptr is pointing to this 20. So this is one object, this is another object. Okay, two objects, value of a is different for them. Okay, now we are showing x2 is a is 20, ptr is 20. Now for x3. So now x3 we are doing the same thing that we have done here. x3 equals to x2. We are trying to initialize x3 by x2. Okay, so what happened if I try to do this thing similarly for x3, then one unit will be there. Okay, one object will be created. So let us see this one. So x3 is basically initialized by the address of the old object x2 and then they both point to the same location. Okay, so this is the problem. Okay, so what happened when we you consider the first figure, when we consider x2 is same. Okay, now when we create x3 is pointing, x3 is having similar variables, data members a and ptr. Okay, and they are copied as it is. Okay, so x3 basically initialized by the address of the object x2. Okay, so x2 is bitwise copied. Okay, so I have told here, I have mentioned that bitwise copy of x2 equals to x3 is done. Okay, so with the here also there is no other constructor, no copy constructor defined, so it is calling the default copy constructor that is supplied by the compiler. Okay, so for this line, so if I do this thing, x2 bitwise copied to x3. So what happened? x3 will be initialized by the address of the old object x2 and they both points to the same location. Okay, so in case whenever we do that, x3 is pointing to the same location because it is bitwise copied. A is copied, PTR is copied. So PTR pointing to this location. So this PTR also pointing to this location, same location for x2 and x3. Now what we are doing, we are trying to change this value of A, we want to change the value of PTR using K. Okay, that's why this is the significance of this function. With this function, we are changing the value of PTR. Okay, so PTR was previously 20. For x3, it is 20. Okay, now after this, x3 is equal to x3 point FB, that is 25 is passed. So if I pass 25 here, so this FB function is called and 25 is initialized to star PTR. So previously your PTR is pointing to 20. Value at PTR is 20 for x2 and x3. Now x3 has changed this value to 25. Okay, are you getting my point? What we are doing actually? Is it okay? Are you understanding
Yes, ma'am.
this?
Yes, ma'am.
Okay, so here the value, only one copy of the value is there, which is pointed by x2 and x3. Sorry, this PTR. Okay. Now with this function, x3 change this 25. Okay. Now if I write down this one, if I write down x3 dot show, it is showing 20, A 20 and star PTR is 25. Fine. This one is fine. Okay. After this, we come to end of this block. So I told that whenever any block is there and you define something within that block, whenever this block comes to an end, this object will be destroyed. Okay, automatically it is destroyed. So this destructed is standing for this destruction of x3. Okay. Next we are coming back to x1. Okay, so we have not made any change to x1. So if I write down x1, for x1, this is fine. Previously this one and this one is same. Now if I show x2, so what it is showing, previously x2 is showing 2020, but now it is changed, it is showing 2025. So value of x2 gets changed even if we are not changing it. We are changing the value of x3, but it gets changed. Okay, again if we do this thing, we are initializing x4 using x2. This is one more initialization, one more format where we are calling the default copy constructor. So if we are doing the same thing, see this is also doing with x2, 20 and 25 is initialized. Okay. So previously our value of x2 that we have written, so this value is not remaining. This value is not retaining. Okay. What we are getting? We are getting the changed value. And at the end, even if we are not calling any destructor, it is called 3 times for x1, x2 and x4. Okay. I'm coming to this destructor thing later. I'll be showing you some example. So this thing you understand. What is the problem? If we have any, means if we are using any default copy constructor here, it is copying x2, bitwise copying x to x3. Okay, so everything is copied. Value of PTR, value, everything. And as they are pointing to same memory location, then if you change the value, always the change value will be reflected. This value, it's gone, it is deleted. Okay, so this should not be done. If we are means doing this thing, we must protect our data, isn't it? So there comes the idea of having our own copy constructor. Okay, so this ambiguity can be solved by having our own copy constructor. Okay, so this is why the copy constructor we cannot pass this type of thing, cannot do, this is wrong actually. Okay, we cannot do pass by value, rather we need to have pass by reference of the object. So you all know that how to pass by reference. So this is a basic form of passing by reference, and you can use const keyword for this one. Okay, so this both of these are same. Okay, so whatever we have declared, this the copy constructor member wise copies the object passed as parameter to it into the object for which it is called. So object whose reference is passed is protected from accidental changes by const keyword. Okay, so this thing already discussed. So what happened if we change this? If we include this, so this is our constructor that we are including. Okay, so how we are writing, this is the constructor body. Here we are just creating means it is this reference of x is passed. So what we are doing, we are creating for x3 whenever it is called, we are creating a new array with x dot a elements. So whatever value of x, this is the reference of object is passed. So whenever we are passed, we are passing x2. For this example, whenever we are doing x3 equals to x2, we are passing x2. So now x2 is mapped into x. Okay, so this x dot a means x2 dot a, and x2 dot a is we are using x2 dot a to create array of 20 integers, and then we are assigning x2 dot a to a, and we are copying bitwise. We are copying each of the element of this new this old array to the new array. Okay, so these three things we are doing. So we are copying this thing, and in this way they are creating a different array. They are not creating, they are not pointing to the same array. Here we are, what we are doing, we are creating a different array using the size. We are passing the size from this x2. We are bitwise copying. We are copying every element of this array that is pointed by x2.ptr, and we are just writing down x2.ptri to ptri. Okay, and we are creating a totally different array, totally different set. So now if we change x3 with fb function, if we change x3, it will get changed as 25, but we are getting x2 as it is. Okay, so this is how we are doing. See, this is the example. This is the whole example. Okay, so here I have included this copy constructor, the same code I have written here, and doing the same thing. First x1 is showing 10 10. For x2 it is showing 20 20. Next, to differentiate that, the copy constructor is where our copy constructor is called, we have added this line. Okay, so whenever we do this thing, x3 equals to x2, so previously the copy constructor was not, the default constructor was called. Okay, but now our constructor is called. So whenever we do x3 equals to x2, compiler ignores the default one, and it will be checking out the supplied one that is done by us. Okay, so it is just calling copy constructor, and it is initializing value 25 by this one. First it is initialized value with 20, then it is changed as 25. Okay, and when we come out of this block, this is distracted. This means the x3 is distracted. After that, again we are calling x1 and x2 to see that whether their value gets changed or they are remaining same. So you see here for x2 10 10, and for for x1 10 10 is there, and for x2 10 20 and 20. But previously it was 20 20 and 25. It gets changed to 25. Okay, so it is not changing. And then if we are doing again, we are doing this thing, x4 is equal to x4 is initialized with x2. So again the copy constructor is called, that's why it is written copy constructor. And this is how the x2 is initializing x4. So we are getting 20, 20. And all are destructed at the end of the program. Okay, so are you getting my point? Why it is required to have our own copy constructor in which situations? Okay, so this one is known as deep copying, because we are going in deep and we are copying not only bitwise copying, that is not only roughly copying this one, okay, from one to one. Rather, we are going deep into the pointers, and then we are checking out where the pointer is pointing to, and that using that only we are copying. So that's why it is known as deep copying. We are going into depth. That's why. Okay. So sir has already discussed, I think, this one. What is the difference between shallow copying and deep copying? So this is, I think you understand. So this is one simple example of copy constructor. Just a second. Okay. Just a second. Okay, so this is just a simple example I have included here for copy constructor. So you understand this thing. Here I am just passing three different constructors. We are having three different constructors. First one is a default one. Second one is a normal parameterized. Third one is also a parameterized, but we are passing the reference of the class. Okay, the same object. Okay, just a simple thing. So next is this is one more example. Let me show you the working of this example. Yeah, this one. So here what I have done, here the same thing. This is the default one. No body is there in the default constructor. And this is three different constructors. Last one is the copy constructor. These two are a little bit different. So here what we have done, this one, passing default arguments. Okay. Okay. And this is normal argument. So just we are calling a box object having three length, breadth, and height, three data members, and we are just returning its volume. We are calling the volume. So here for the first one, we are passing three values. So it is matched with this one function. You just recall the function overloading thing. Even if we are having different function similar arguments, the compiler differentiate in its way. And then for the second one, box 3, the second one is called. So if I run this one, just you see what happened. Okay. So this is for the box 1. It is showing 210, and the second one 10 and 0.0 and 2.0, 12.0 it has taken, and I have not passed anything here. So it is taking 5 and this is 600, and we are just copying this thing box 3 to box 2. So it is also showing 600. Okay, so here with this example we are showing all the three things, that is how to pass default arguments, how we are having different parameters constructor, and how we are maintaining the overloading of function as well as the copy constructor. Okay, I think this thing is clear to all of you.
Yes, ma'am.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
So next is let us see what destructors are. Okay, so it is used to destroy the objects that has been created by the constructor, and as the name signifies, it deallocates the space that is allocated by the constructors, and it resets the default values. Okay, and the name is same as the constructor name, but it is preceded by a tilde sign. Okay, this sign, and it will not pass anything or never return any argument. So basically we cannot overload the destructors. We can overload the constructors, but destructors are not possible to overload because we cannot pass any argument, isn't it? So it is called implicitly by the compiler during exit of the program. So till now we have not written our own destructor. We have not written any body, anything we have not written. But even if you are not written anything, compiler will be supplying one default destructor. Okay. And destructor may be called even if there is no user defined constructor defined explicitly. Means even if you are not defined any constructor also, they will be called. Okay. So it is a good programming practice that we can use our own destructors to deallocate the memory after use. Okay, so let us see one small example of how it is done. So I have taken very small example. Okay, so here what I'm doing, let me show you the code here. Yeah, the same code I have copied here. So what I have done, I have created one variable. This is global variable. Okay, I have created this to maintain the count. Okay, the overall global count. This variable is initialized with 0. Then I have created one class alpha. Here, this is the constructor for alpha. Okay, so what we have done for the whenever any object is created for alpha class, this one will be called, and the objective means, sorry, the objective of having this constructor is whenever any object is called, I'll be increasing the count by 1 and I'll be showing the count, and whenever any object is destroyed, then the count will be decremented by 1. Okay, so just a simple one. So here, this is the body of alpha. This is the body of destructor. So here I have not passed anything. We are just showing how which object is destroyed and then count minus minus. Okay. So just check out the execution. So in main, we are creating 4 objects: A1, A2, A3, A4. Okay. So for A1, whenever we call any object, this will be called. Okay. So for A1, what it will show? Count as 1.
1.
Isn't it? 1. For A2, again it will show count equals to, this is a global count,
2.
2. For A3,
3.
3, and for A4, 4. 4 objects created, so it will be showing 4 lines, number of objects created, then 1, 2, 3, 4, like this for this 4. Okay. Now what I have done, I have created 2 blocks. One is this is block 1 and this is block 2. So I told that whenever any block is created and within that block, if I call anything, if I create anything, when it comes to the end of this block, the destructor will be called automatically. So here we are created one more object A5. Okay. So what it will print for A5?
3.
3. Why 3?
It is decremented by 1.
This is in first it will show, first it will write down enter main. Okay. So let me just write it down here. Yes, let me just. Okay. So first one is enter main. This one, this line will be printed. First one. Okay. I'm writing here side by side. I'm writing here and the output. Okay. So it will be showing enter main. Then in the next line for A1, A2, A3, A4, it will be showing What? For A1, A2, A3, A4, for all of them, 4 statements will be created. Number of object created. Every line 1, then 2, then 3, then 4, it will be printing. After that, it is entering for this line, it is entering. So it will display enter block 1. Okay. Now for this one, what it will print?
5.
Number of object created equals to 5. Okay. For this line,
4.
must print 4, not 3, because it is decremented. But first it is incremented, na, for A5. Are you getting?
Yes, ma'am.
So it is showing number of object destroyed. Now the destructor is called. So it will show number of object destroyed as 4. So what will be the next one? So let me just run it now. Okay, show you the answer. See the answer. Okay, I'm skipping this one, keeping this one. Okay, so for this one, enter main. So let me just put some indel. Enter main, then number of objects created 1, 2, 3, 4. So this is for A1, A2, A3, A4. Okay. Next is we are entering into the block. Enter block 1. So it is showing enter main, then in main 4 objects are created. That's why this is, then it is coming inside the block. We are not calling here destructor, but we are coming out of this block. That's why it is writing number of object destroyed is 5. So why it is 5? Why it is 5, not 4? This is the idea of C. You can tell me.
The decrement is done after.
Because decrement is done afterward. First it is printed. So value of when it is printed, its value is 5 and then it is decremented. Okay. So when it comes in the second block, it is telling enter block 2. So for A6, the 6th one is created. But it is showing object created as 5. Why 5? Because it is decremented here. When it comes out of this block, it's decremented here as 4. And then again when A6 is created, it is showing 5, not 6. Is it clear?
Yes, ma'am.
So again, when we are coming out of this block here, it is calling the destructor. So it is showing destroyed 5, destroyed is 5 and it is decremented by 1. And after that it is coming re-entering main. So re-enter main. And after this return 0 and then we are coming out of this block. So this is the main block. Okay. So we know that whenever we come out of any block, whatever objects are created inside that block will be destroyed. So the 4 objects that are created within this block is A1, A2, A3 and A4. So all of them get destroyed and each of them while destroyed, the count decrements by 1. That's why for 4 objects, 4 destructors are called and every time the count value is decreased. So 4, 3, 2 and 1. So this count value is actually taken to show you how many times the destructors are called and how they are working. Okay. So this example I have considered this count value for this one. Okay. But it's not exactly whenever you use destructor, it is not required. Clear? You understand this part? How the destructors are called and how they work. Even if we are creating one more block here, you can see let me create one more block here. Okay, this is block 3. And let me create 3 more. Now 3 more objects. Okay. So if I run it, see what happened. First 1, 2, 3, 4 is called. Then block 1, 5. Then block 3, what happens? Created 5, 6, 7. And when it destroyed, 7 is first destroyed, then 6, then 5. That means 7, 6, 5 means every time it is calling this A7, A8, A9, every one is created, that time it is incremented. And when it come out of this block, here it gets decremented. The destructors are called. Okay. And we again re-enter main, and in main we have 4 objects. If I have here one more object, say A9, sorry, A10, okay. So that time it will work in this way. See. So 1, 2, 3, 4, 5. For this one, 5 objects are created. So the count goes up to 5. Then for this block 1, this count is 6. For block 2, count is again 6, because when it comes out of block 1, it decremented. So it's 6, again 6. And again for this block, 3 objects are created. So 3 objects are created, 6, 7, 8 with this 3 line. And then again they are destroyed. So upon destruction, the count gets decremented. So 3 times the destructor is called. Again they're coming to main, 5 objects are destroyed. So are you getting my point?
Yes, ma'am.
Yes,
The count variable is just to demonstrate how the destructors are called. Okay. It's not like that you are how many objects you are creating or how many objects are destroying. It's not like that. I'm just showing that destructor is called and constructor is called. You can just change the value here. Constructor called and destructor called. Okay. So from now onwards, we'll be using this one, constructors and destructors. Okay. So up to this is the chapter, this chapter called constructors and destructors. Okay. So here I have included the output. Okay. So it will be now whenever you create any classes, like it is given some stack queue and some matrix class is given, so that one you can do. Okay. And there was one question, I think, for the heap. Okay. What was the question? That extract, what is the use of extract? Okay. You one in find min, you can find the minimum or find the maximum, and then extract means you just delete that one. Okay. Delete from this list. I think I have.
And there is also another function.
Yeah. That will be an or function. In between that will be an or. Okay. I have just written, but I made some mistake in the assignment. There is also delete function, na? I have written something like delete min or delete max. So extract and delete both will do the same thing. Okay.
Okay.
Okay. So next class, sir is going to start operator overloading. So do you know what is operator overloading is? Any idea?
Making the operators work differently according to
you are
the.
telling that with plus operator can I do minus, or with plus operator can I do multiplication? Are you changing the meaning of the operator?
Not completely, means according to our class we can specify the operation of that operator, means what we want to do with the operator.
I'm giving you a simple example. Okay. Just I'm giving you a little bit introduction of this operator overloading. Just a simple. Okay, so if I do this thing, A plus B. Okay, so here two operands are there for plus operation. Two operands are there. So let us say A and B is integers. Okay, so we can do this thing. So this is known as binary operation. If I do this thing, this is ternary operation, and we can do this thing for n numbers. So we can say this is n array operation. Okay. So the meaning of this operator plus, is it changing? Is it changing?
No, ma'am.
It is not changing. So we are not changing the meaning. Rather, we are increasing the number of operands. And by that, we are doing binary operation or unary operation or ternary operation or n-ary operation. So the operation is different. That means same operator, sorry, my slate is not doing correctly. Same operator, sorry, and different use. Okay. So this is actually known as operator overloading. So we know that meaning of overloading is one particular entity will be having different roles, isn't it? Like teacher is having, I am a teacher, I am having a role of warden, I have to play a role of researcher, or sometimes I am playing a role of student. Okay, so different roles. So I can say that I am overloaded. Similar way, if we give different use, if we use a simple same operator for different purpose, that is known as operator overloading. So why it is required? Because the answer is same. We can have some built-in data types, and we do the same thing. We do these things with built-in data types like a plus b. We are adding two integers, two floats, etc. Then we are creating our own variables, own class variables. That is, we are having our own objects. So can I add two objects directly without writing down any function? Okay. So how can we add this thing? If I want to add two objects and then I'll be returning this to some other object. Can I do that? So for this, we need to overload this operator. We need to give its, we need to write down the meaning, explicit meaning of the operator, that what it should do. We will be defining its behavior. So how we are defining the action or behavior? With some member function, isn't it? For an object, when we define the behavior, we are defining them through some functions. So for operators also, there are some operator overloading functions that we need to write. Okay, so there are certain syntax for writing operator overloading functions. There are certain facts related to how you are using a member function as operator overloading function, or how you are using the friend function, or in which situations. Recall the friend function that I have told you. It's friend to all the class. You can access the private data members for 2 or 3 different classes. Different classes private data members can be accessed by friend function, and they are not member of any function, but they can access the members via objects and dot operators. So again, we will see some example or some basic, means some particular specific use of friend function in operator overloading. Okay. So we'll see this thing in the next class. Sir is going to take operator overloading part, and also I think he'll be teaching you the static variables and static member functions. And after that again, I'll be taking care of the inheritance part. Okay. So till now, do you have any other query or anything else that you want to share?